Hello, good evening. We are team BizWizards, and first I'd like to introduce my team. We have Deepak Baisala, Himani Valecha, and myself, Shekhar Mandal, for the same. We are part of consultancy, and we are going to present our case on Prairie Airlines. Before onto the solution that we present,
Guys, बहुत ज़्यादा noise आ रहा है, please. It's being recorded into the video, alright? Please sit down.
okay, before we go into the solution, let's have an overview. Starting with what is Prairie Airlines. Prairie Airlines is an LCC carrier in US domestic industry. It is operating over 202 routes and 39 cities for the last 5 years, but has been facing losses in the last 2 years. Now, what's the problem statement? The problem statement is that since it is losing out its customers, it has to scale up its production and expand its operations. Now, for that, it has to identify all the profitable routes and locate the major cities as a maintenance hub. And third step is, how do we go about doing this? Starting with the preliminary analysis that was done using descriptive statistics. Second was finding out the model that best suits our data. Since the data that was given was a panel data, we looked into both the models, fixed effect model and random effect model. Though Hanselman test shows that fixed effect model is a better fit, but on looking into the results, we found out that one of the significant variable, distance, which is time stationary, was being dropped, and it had very significant effect on fare. So, though it was shown that fixed effect is a better model, we selected the random effect model to capture the effect of distance. Next is the interpretation of the results, and finally our recommendations. Now, before we start with our analysis, there are certain assumptions that we have made. First and foremost is cost per kilometer is constant. We were asked to calculate the profitability, but only revenue is given and nothing is mentioned about the cost. So profit can only be calculated when assumption of cost per kilometer is constant or some assumption is made. So we have made this assumption. Second is the route list for the given city is exhaustive. This is also a very important assumption because there are cities for which there are no round trips, and so we have taken that there are connecting flights and no direct flights to these cities. And finally, there are only 39 cities that we need to consider, though there are a lot more in US. Now next, having a small brief about the data. Total number of cities that were taken were 39, number of routes 202. Data was available for 4 years, and the attributes that were given to us was distance, passenger, and concentration ratio of the biggest market share. Now, on descriptive statistics, we found that there is a linear relation between passenger and concentration ratio with the fare, but a non-linear relationship between distance and fare. Next, we checked for multicollinearity, and the multicollinearity was very low, and this was calculated using variance inflation factor, which came out to be around 4. Next was heteroscedasticity. There was heteroscedasticity in the data, and we used the robust method to eliminate that. Next slide will be taken up by Himani.
So coming to the next slide, which is about descriptive graph, we'll start by the first graph, which is for the fare over different routes over the different years. So it was observed that over the different years, the trend was same, that either it was increasing or decreasing in all the routes. And another insight was that starting from year 1997 or 1998, it was increasing, which will be further justified in our regression results. The next graph that we have is of average passenger, and it was observed that in all the routes, the average number of passengers over the years were increasing. The next graph is for distance versus fare, and it was shown that it was following a non-linear trend. So this is one of the reasons that in the next slide that I'll be showing in our regression result, we have taken distance square as a factor because it captures the non-linearity factor. So to find the key attributes, we did a regression and we got the following result. So starting from the first coefficient, that is of intercept, it captures the base year effect, which is of 1997, and also all other factors which are not included in the model. The next coefficient being that of year coefficients 1998, 1999 and 2000. These are difference coefficients which shows how much the fare differs from that of the base year 1997. So for example, in 1998, it was 0.037% more than that of in the year 1997. Coming to the next coefficient, that of passengers, we took log of passengers and we got a negative coefficient. So it implies that as the number of passengers that changes by 1%, the fare decreases by 0.28%. Similarly, for the next two coefficients for concern and distance square, we got the positive coefficients, which shows that as the coefficients increases by 1%, as the coefficient increases by 1%, the corresponding change in fare is also that of 0.11% and 0.03%. So to summarize, that is a model given in the top, and distance square accounts for the non-linear trend, and fare has been increasing over the years, which is justified both by a regression result and as well as the graph. The last one being that distance concentration has a positive impact and passengers have a negative impact for the fare.
The first question which was asked from us was about the most profitable routes. The total number of routes were given 202. So we have analyzed the routes based on three criteria. First one is the average revenue per kilometer, which gave us the profitability. And next is the growth in the average revenue per kilometer. And we have to also take it into account the total revenue, because we cannot just look at the growth, we have to look at the base as well. So with respect to average revenue per kilometer, these are the routes which shows the maximum revenue per kilometer. These are generally the routes from the major cities like New York and Washington. And next, we are seeing the growth in average revenue per kilometer. As we can see, in some routes, the growth is over 300% over 4 years. So, and the last one, we have to see the total revenue for different routes. Again, the major cities compromises of the total revenue percentage. So based on the three parameters that I mentioned in the last slide, we have come up with these routes which are the most profitable routes, and the procedure to exactly pinpoint the most profitable routes, which are 10 in this case, that we forecasted the average revenue per kilometer for the next 1 year, 2 year, and 3 year, and see what are the common routes in those forecasts. So these are the 10 routes which are there in the 1 year forecast, 2 year forecast, and 3 year forecast. So we will be concentrating more on these most profitable 10 routes.
Now next is coming to high performing cities. To select high performing cities, we have taken different parameters into consideration. Starting with distance, it's the total distance that is covered. So we are taking the coverage ratio that is into consideration. Second is the revenue, or we are saying what is the total revenue or total earnings of the company. Third is the revenue growth. It means how is the company performing over the years. Again is average revenue per kilometer. This is also very important because it gives what are your real profits. Coming next is frequency of flight. This is also a very important factor because this shows that how good your connectivity is. And finally, revenue growth. This is one of the factors, or this shows the sustainability of the company. So based on these factors, we chose 20 companies, or sorry, 20 cities in each and every one, and based on subjective judgment, we came up with finally 4 cities. And the cities are New York, San Francisco, Seattle, and Washington. When we see the distance, we see that 26% of the total distance covered are being handled, or the total distance of 26% is handled by these 4 cities. Again, coming to passenger base, 31% of the total passenger base of our sample is covered in these 4 cities. Again, revenue, these 4 cities generate 42% of the total revenue for Prairie Airlines. Also, the frequency is very high. We are given 39 cities, but these 4 cities constitute 21% of the total revenue. Total frequency is 21%. That is, number of flights are very high. So, one more thing, we have seen that New York is high for all of this thing. How we have taken high, whenever a value is more than twice the average for distance, passenger, and revenue, it's high. And if it is greater than 120% of the average For average revenue per kilometer, frequency and growth, it is high. So we can see in these four cities fare highly in most of the parameters except for growth in New York because the base is very high when compared to other cities because there was a difference of around 30% between New York and the second city, that is San Francisco. Next, we are done with the data. Now we'll be doing the market analysis and coming up with the recommendation. This will be taken up by Himani.
So to analyze the market, we did it through Porter's 5 forces, and what we got was starting from the bargaining power of buyers, which is very high. One of the reasons being that the number of buyers, the customers, are very high, and this being the LCC, the switching cost is very low. The next is bargaining power of suppliers of aircraft. They being the less in number, this again the bargaining power of suppliers is very high because of the number being less, high switching cost, and the high brand value attached. The next is the threat of substitutes. Again, being the LCC, there's a lot of threat from other LCC and FSC, but there's a moderate threat from other modes being road, rail, and marine. The next factor is threat of new entrants. The airline industry being a highly capital intensive industry and highly regulated, there's a very high threat of new, with this very less threat of new entrants, also because of the factor of low growth. The next and the most important being the competitive rivalry. This being the LCC, there's a very less product differentiation. So that constitutes a lot of towards the competitive rivalry. And also there is a very less customer loyalty. So these are some of the recommendations that we made starting from the operations and services. The first one being the aggressive fuel price hedging. Because of the volatility in the prices of fuels, it is very important to hedge so as to mitigate the risk and to make the better management decisions. The next one being operation enhancement at profitable routes by providing MRO at all those cities which have lesser maintenance cost. The next one being providing only one kind of aircraft so as to reduce the engineering cost which is attached with the multiple routes. The next one is no travel agents, only direct booking so as to maintain the linear coverage. The next one being paid meals, snacks and beverages. The most important one being fast turnaround, unload a flight which includes unloading a flight, cleaning and reloading.
Thank you.